For this tutorial, I'll be demonstrating how to access the habitat connectivity data from the Washington Wildlife Habitat Connectivity Working Group's Cascades to Coast analysis, as well as providing a brief discussion of those data and where to access additional resources. We'll start on the home page for the Cascades to Coast Landscape Collaborative. From here, we'll hover our mouse over the Resources tab at the top of the page, and we'll select the Northwest Conservation Mapper tool. We'll wait a moment for the tool to load. And once the Mapper tool opens, you'll be presented with a splash screen that provides a brief description of the tool. And it also includes a link to the user guide. And it also includes a link to a video tutorial that gives a full walkthrough of the Mapper tool. But for right now, we'll focus our discussion on the habitat connectivity data. So once we close the splash screen, there are two layers that are initially displayed. We have a priority wildlife crossing areas layer and an overlapping habitat connectivity corridors layer. And let's just zoom in a little bit and recenter. We'll start with the overlapping habitat connectivity corridors layer. And to get an unobstructed look at the layer, let's turn off the priority wildlife crossing areas layer. And we'll do that by using our mouse to click on the image with three lines in the upper right corner of the screen. And when we hover our mouse over the image, it says More. So once we click that, we'll open up another panel and we'll select the box that says Connectivity. And this will open a panel to the right where we can turn on and turn off the connectivity layers. Let's turn off the priority wildlife crossing areas layer. And we'll do that by clicking the checkbox. For a bit of background context, the Cascades to Coast analysis, it modeled habitat connectivity for 5 species, as well as for the landscape more generally. And this was done as a way to map the routes that wildlife are expected to move along. And by stacking those maps on top of each other, we get the overlapping habitat connectivity corridors layer that's on the screen right now. And we can see certain patterns begin to emerge. We have these broadly connected areas along the western slope of the Olympic Mountains. And these are at low to mid elevations. And these continue down into the Willapa Hills, over to the mid elevations of the South Cascades, and up into the mid elevations along the western slope of Mount Rainier. We can also see where natural barriers can fragment and divide the landscape to impede wildlife movement. For instance, the higher elevations of the Olympic Mountains, Mount Rainier, and the South Cascades. And we can see where there are any human-caused barriers, like roads, highways, or development. And these have a pattern where corridors are long and narrow, like along Interstate 5, along Highway 12 and Highway 8, between Aberdeen and Olympia. Also along Highway 12, east of Interstate 5, and around Joint Base Lewis-McChord. Now, we'll take a look at the priority wildlife crossing areas layer. So let's click the checkbox to turn on that layer. So this layer shows locations where the highest priority corridors for each species overlap and intersect major highways. And these priority wildlife crossing areas are symbolized by annual average daily traffic. For areas with a relatively low traffic volume, less than 5,000 vehicles per day, like those in yellow, they tend to include corridors that are fairly wide and where wildlife, for the most part, can freely move across the landscape. These are areas where there's a greater emphasis on the importance of prioritizing efforts to conserve these existing corridors to maintain their habitat connectivity. On the other end of the spectrum, where there's greater traffic volume, more than 10,000 vehicles per day, like the areas in red, they tend to coincide with areas that also have greater development along both sides of the highway. And for these areas, there's more of an urgency to restore habitat connectivity along these corridors. Somewhere in the middle are areas with intermediate levels of traffic, like those in orange. The threat from traffic is not as high, and they vary in terms of the extent of development and how freely wildlife can move across those parts of the landscape. For these areas, additional assessment in the field is likely needed to determine whether there's a functional corridor at the location that needs to be conserved and maintained, or whether additional actions are needed to restore habitat connectivity. So let's turn off the two layers we've been working with and take a look at the other layers that were used to derive them. And we'll use the Fisher habitat connectivity layer as an example. In this layer, we see habitat concentration areas, which are areas where there's a high concentration of suitable habitat for the species. And for Fisher, that's mainly in the Olympics and the Cascades. We also see in this layer the corridors that connect those habitat concentration areas. The corridors are symbolized by least cost corridor width, and a technical definition of that is that it's a measure of how far away you are from the center of a corridor based on the accumulation of least cost distance as you move outwards from the center of that corridor. So what does all that mean? Well, these corridor widths are a reflection of the different types of habitat present on the landscape and how easy or hard it is for a given species to move through those habitat types. For Fisher, it can move relatively easily through forest habitat, so there's a low movement cost, whereas developed areas are more difficult to move through, so there's a higher movement cost. Traveling 5 kilometers of least cost distance through forest covers a much greater geographic distance than traveling those same 5 kilometers of least cost distance through a highly developed area. You end up traveling a much smaller geographic distance because of the difficulty of moving through that type of habitat. Looking at the corridors in the Willapa Hills, where there's quite a bit of forest habitat, the central portion of the corridors, that 0 to 5 kilometer least cost range, is fairly wide because of how slowly that movement cost adds up as you move outwards from a given corridor center. But along Interstate 5, where there's a lot of development, movement cost adds up very quickly. So that the central portion of the corridors, that 0 to 5 least cost range, is much narrower. This means there's less flexibility for where a particular conservation or restoration project can take place. For a given corridor, the wider that central portion is, the more options that might be available for choosing a project site. In addition to Fisher, we have connectivity maps for American beaver, cougar, mountain beaver, western gray squirrel, which has a more limited range, and landscape integrity, which shows connectivity for the landscape more generally. The landscape integrity layer looks a little different than the species layers. It comes from a separate analysis that was part of a previous project. It used a different set of movement costs to model how easy or hard it is for wildlife to move through particular habitat types. Higher values were used for those movement costs, so those costs accumulate much more quickly when you move outwards from the center of a corridor. So even though the corridors look really narrow, the routes they follow, especially where they cross the major highways, are generally consistent with the corridors for the individual species. If you're interested in more information about a particular layer, you can head to the panel on the right-hand side of the screen and use your mouse to click on the 3 dots to the right of your layer of interest. Select Show Item Details, which will open up another tab in your browser where you can access that information. The description section discusses how the layer was derived from the original connectivity data. And if you'd like to access those original connectivity data, you can do that from the Cascades to Coast Landscape Collaborative website. Let's head back to the CCLC homepage, which I already have open in another browser tab. And we'll hover our mouse over the Resources tab at the top of the page, and we'll select Spatial Design Tools, Products, Reports. And we'll scroll down a little bit down the page to the Habitat Connectivity Analysis for the Cascades to Coast region of Western Washington. And in this panel, we have links to download the connectivity data at its original 30-meter spatial resolution. So you can see what the data looked like in a much finer scale before it was summarized into those larger hexagon grid cells that the CCLC spatial mapper tool uses. Those links also include supplemental data layers beyond what was added to the Northwest Conservation Mapper tool. All the data are available in multiple file formats with accompanying metadata, and there are links for each species, for landscape integrity, and for the synthesis analysis, which has the overlapping habitat connectivity corridors layer and the priority wildlife crossing areas layer. We also have links to a technical report and links to a connectivity webinar, both of which discuss these connectivity data in much greater detail. And if you're interested in learning more about the group that produced these connectivity data, you can head to the Washington Wildlife Habitat Connectivity Working Group website. We'll click this link right here. Here, you can find out more information about the Coastal Washington analysis, that Cascades to Coast analysis, as well as previous connectivity projects that this latest project built upon. And that concludes today's tutorial.